Hello, good morning, welcome back to the another lecture. In last lecture, we discussed some important terms regarding the transmission line such as feeder, distributor, service mains, transmission line. Feeder is a line between main substation to the local substation. It may be on 11 kV or up to 66 kV. And the distributor are line between local substation to the near surrounding. It may be on 440 volt or more. While service mains are line connected between our houses to tower. And transmission line is conductor or lines connected between generating station to the main substation. It may be up to 800 kV or more. Now, let us start with switchgear equipment, also known as element of power system. In power system, mainly 6 type of switchgear elements. First one is switch, second one is fuse, third one is relay, fourth one is circuit breaker, fifth one is current transformer, and last one is potential transformer. Since in past we already deal with current transformer and potential transformer, so these two are not included in our discussion. So only we focus on remaining 4, that is switch, fuse, relay and circuit breaker. Let us start with switch. Switch is a device which is used to open or close an electrical circuit in convenient way. It can use under full load or no load condition, but it cannot interrupt the fault currents. The switch may be classified into air switch, isolator and oil switch. This one represents a switch layout. Having fixed contact and a moving contact. Suppose switch carry 100 ampere current. When moving contact try to separate from fixed contact, an arc is struck between the fixed contact and moving contact. If arc quenching medium is air, then switch known as air switch. If medium is oil, switch known as oil switch. Now, air switch. This one is an example of simple air switch which is widely used in our houses and having rating of 5 ampere, 15 ampere, 25 ampere and more. While this one is used in power substation. Construction and working of this one is very simple. We try to understand its working with a video. This arc represents switch is operate on load. Due to this arc, air switch has some limitation, like air switch cannot be used in indoor application. And other one is it cannot be used to break high ampere current. Basically, air switch is designed to open a circuit under load condition. Next, isolator. It is designed to open a circuit under no load condition. It is also air type switch. In this image, this one is an isolator. Let us understand working of isolator with the help of a video. This one for R phase, this one for Y phase, and this one for B phase. And here we can see when isolator try to open, there is no arc produced. That means isolator operate on no load condition. Isolator main purpose is to isolate one portion of the circuit from the other. Let us understand with the help of this diagram. This one is circuit breakers. And this one is isolators. Whenever circuit breaker demands scheduled maintenance or some repair work, with the help of isolator, we disconnect the circuit breaker from the line. Next, oil switches. Oil switch can break high ampere current. In this, arc quenching medium is oil. With the help of pressure switch, we can separate moving contact from the fixed contact. Next, fuse. They can sense the abnormal condition and interrupt the current. This one is an image of a HRC fuse, and this represents its rupturing capacity, and this one represents the layout of a HRC fuse. Fuse is a short piece of wire or thin strip which melt when excessive current flow through it for sufficient of time. It is connected in series with the circuit to protect them. Under normal operating condition, the fuse element temperature below its melting point and carries normal load without overheating. However, when short circuit or overload occurs, the current through the fuse element increases beyond its rated capacity. Operating temperature increases and fuse element melt or blow out, and the circuit is disconnected from the supply. The main drawback of fuse, we can use only once. After the operation, we have to change the fuse. Now, circuit breaker. Circuit breaker is an equipment which can open or close the contact under all condition, that is no load, full load or fault condition. It is designed such that it can operate manually or remotely. Under normal condition, it operates manually, and under fault condition, it operates automatically with the help of relay. Under normal operating condition, the contact remains closed and a circuit breaker carries full load current continuously. This one represents an oil circuit breaker. Let us try to understand the circuit breaker working with the help of an animation. Circuit breaker having two contacts. First one is fixed contact and other one is moving contact. And for this circuit breaker, arc quenching medium is oil. When moving contact, try to separate from fixed contact. Arc is struck between moving contact and fixed contact. So we can note a point here, a circuit breaker can operate on normal as well as abnormal condition. And last one is a relay. A relay is a device which detects the fault and supply information to the circuit breaker for the interruption of current. Second figure shows some important terminal information of relay such as SPST, DPST, SPDT, DPDT, where SPST stands for single pole single throw. That means relay has only one moving contact and can connect with only one point. Next one is DPST, stand for double pole single throw. That means relay has two moving contact and each moving contact has only one contact. Moreover, here NC represent normally closed and NO represent normally open. That means when relay coil is energized, NC contact remain closed, and when de-energized, NC contact will open. I hope you all enjoy the lecture. Thanks for watching.